Okay, so I've never tried this before, so we'll see how this goes. So I'm going to try to do a video where I have this being recorded. So this is problem number 61. It is 4 times x plus 1 to the half power minus 5 times x plus 1 to the 3 halves power plus x plus 1 to the 5 halves power, all equal to 0. So you notice here we have these exponents, and they're all being applied to the same term. So U substitution is great for a problem like this, and we have these fractional exponents. Um, in this case, since all three of them have a fractional exponent, we want to let our U equal the lowest power. If we had an example problem where we only had 2 and then we had a constant, we'd probably want to make it be the middle term. Like you probably want to make it be this one. But since we have all three of these, um, we're going to want to make it be the first one. And I'll show you a little bit more why in a second here. So let U equal x plus 1 to the 1/2 power. Now there's another reason that we want to let U equal that. So if we do that, so if we have this exponent and we cube it, we get x plus 1 to the 3 halves power, because the power to a power exponent rule says that when you have something to the half power exponent raised to the third power, you're going to multiply the value of the exponents together. Ones are going to cancel. We're going to be left with 3 halves. So this, when we raise it to the third power, is this. So that's helpful. So now we can write 4 to the U minus 5 to the U cubed, because we know that U cubed gives us this, which is what we have right here. Furthermore, if we have x plus 1 to the half raised to the 5th power, that is x plus 1 to the 5 halves power, because again, applying the power rule to exponents, if we have 1/2 as our exponent raised to the 5th power, we multiply the value of the exponents together, the ones cancel, and we're left with 5 halves. So our last term is just going to be plus U to the 5th equals 0. Well, now we have a common factor of U. We've got a U here, a U here, and a U here. So let's factor out that U. So we would have U times 4 minus 5U squared plus U to the 4th. And let's rewrite this for convenience sake into a form that feels more familiar. So we can write U to the 4th minus 5U squared plus 4. And now we're going to factor everything completely. So we can factor this expression. Let me scroll down just a hair here. So we can factor this as U times, we have 2 parentheses here. So this factors to U squared minus 1 times U squared minus 4. When we FOIL this, we get U to the 4th. Then we're going to get a negative 4 and a negative 1 U squared. So add those together, you get negative 5. And then when you do the last term, negative 1 times negative 4 is positive 4. So that's how we factor this. And then this is the difference of squares, and this is the difference of squares. So we can factor yet again. U plus 1, U minus 1, U plus 2, U minus 2, all equal to 0. So here we come up with any one of these factors could equal 0, and this equation will be true. So we have U equals 0, we have U equals plus or minus 1, because this would be minus 1, this would be plus 1, and we also have U equal to plus or minus 2. Well, we don't care about U. We care about value of x. Let's plug these in to this equation, and then solve for x in each equation. So if we plug in 0 for you, x plus 1 to the 1/2 power. So another way of writing this, because this looks a little funky, it's kind of hard to simplify this. But if we raise this, oops, actually, no, hang on, let me do that. Let me do this step. 0 equals this to the 1/2 power is the same as taking the square root of this. So these are equivalent. These are equivalent ways of expressing this. So to get rid of the square root, we're going to square both sides because we want to solve for x. All we care about is what is x. So to square both sides, we're going to come up with 0 equals x plus 1. To isolate for x, we're going to subtract 1 from both sides. 1. So x equals -1 is our first answer. We're going to get 2 more. So we can do both positive and -1 at the same, because look what we're going to do here. We're going to square it. If you square -1, you get 1. If you square 1, you get 1. So I'm just going to leave this as plus or minus 1 equals the square root of x plus 1, because again, I'm plugging this value for you. I'm plugging that in right here. That's you. So now we're going to do the same thing that we did when we got here to this point. We're going to square this, and we're going to square this. And again, it's going to be 1 equals x plus 1. Well, if we subtract 1 from both sides, our 1s are going to cancel. So for this answer, we get x is equal to 0. And let's do it for our last pair. We have u is equal to plus or minus 2. So if we have plus or minus 2 equals x plus 1 square rooted. We're going to raise both of those to the second power. Should be using parentheses there. I'm a little lazy with not doing that. You square -2, you get 4. You square +2, you get 4. So 4 equals x plus 1. Subtract 1 from both sides. X is equal to 3. So these are your 3 solutions in the book. So hopefully that helps. Hopefully this screen record actually works. And let me know if you have any questions in the comments.